A very warm welcome to all of you. Myself Rajan Choudhary, Professor in the Department of Civil Engineering, Indian Institute of Technology, course instructor for the NPTEL MOOC course Pavement Construction and Technology, funded by Ministry of Education, Government of India. Our today's lecture, where we will discuss about the skid resistance or the frictional resistance of pavement surface and its measurement. So, at the very beginning, I would like to acknowledge the use of text, informations, graphs and images sourced from various textbooks, codal standards, journal articles, reports, newsletters and public domain searches. Now, skid resistance or friction resistance forms a very important aspect of a pavement surface because it is related to the safety of the users. So, if some of the technical terms which are referred under this particular one, if I mention skid resistance, what it says as per the NCHRP report, it represents the force developed when a tire that is prevented from rotating slides along the pavement surface. So, whenever a vehicle tire which is moving on the surface is prevented from rotating and it slides, so at that moment of the time the force developed between the tire and the road surface is your frictional resistance, or we can call the skid resistance. So, the friction force, normally for any friction force we need two surfaces. So, the friction force defined as the resistance encountered when one body is in contact with the other one. So, here we have the vehicle tire which is in contact with our road surface, is moved or tends to move depends on the interaction between the tire and the pavement surface. So, this will highly depend on the interaction between the tire and the pavement. So, from this particular aspect itself we can get an idea. It will depend upon the characteristics of the tire, it will depend upon the characteristics of the road surface. So, therefore, any factor influencing either the macro texture or micro texture of the surface. Now, the pavement, when we talk about the pavement, usually the surface can be classified in terms of its texture. So, and that texture is further classified into macro texture and micro texture, which we will discuss in detail in coming slides. So, this will depend upon the pavement surface characteristics, I will say, and texture forms a part of the pavement surface characteristics. So, this plays an important role. When it comes to the coefficient of friction, many a times it is referred while we do various computations with regard to the stopping side distance or the design of the super elevation in case of design of horizontal curves. So, one coefficient which is used is the coefficient of friction, which you might have encountered in some other courses also, is the ratio of the frictional force to the normal force. This is what we have, where what is F is the frictional resistance to motion in the plane of the interface and L is the load which is normal to the interface. So, this is what your coefficient of friction is there. Now, specifically when it is related to road surface, the safety of the motoring vehicles or the users is highly dependent upon the skid resistance or the frictional resistance of the surface, and this becomes more challenging specifically when the pavement surface is wet, because this frictional resistance gets significantly reduced in the presence of water. So, the friction in general also, skid resistance and friction resistance plays an important role for the safety, for the safe maneuvering of these vehicles over the surface, and this specifically becomes more important when the surface is under wet condition. So, the friction resistance, or I will call the skid resistance, offered by the pavement surface under various driving and surface conditions. Driving conditions specifically refers to various speeds at which the vehicles are travelling. So, whether that also plays a role in the friction resistance of the surface. So, pavement surface under various driving conditions and surface conditions, there will be the characteristics of the surface, and in addition we have one parameter now which is water. So, is quite important with reference to the safety. The term tire pavement friction suggests that friction developed in any situation involves two primary components, as I mentioned. One is the tire and the other is the pavement. Now, this combination along with makes another critical combination when the third one enters into it, that is the water. When presence of water, you can see when presence of water is there on the surface, this combination becomes more critical. So, whenever water is there, we in general also specifically we always want that this surface should not be slippery, the vehicle should be able to control its maneuverability when it is moving on a wet surface also. So, the friction between vehicle tire and the pavement surface is one of the factors determining the operating speed. If this is challenging, you need to move out at lower speeds. You can see this particular vehicle is traversing a horizontal curve. So, definitely depending upon the radius, there will be some centrifugal force which will be exerted on this vehicle, and this centrifugal force has to be balanced out by what? One is the super elevation which is to be there in the surface. Second is the lateral friction which is there on the surface. So, these two factors will help to have a safe transition over this particular horizontal curve. So, if we are not able to have a good amount of lateral friction, or there is always a limitation with amount of the super elevation, that is what portion you have raised these outer edges with respect to the inner edges, there is a limitation. If that is not able to counteract the centrifugal force, what will happen? You have already gone to the limits of your super elevation, and the lateral friction is having its own limitations. So, in that case you need to bring down your speed. So, operating speeds have to be low. And other is when you want to stop a vehicle, that is a stopping side distance. So, in those design aspects also, you need a good information about the skid resistance or friction resistance of a road surface. Now, if important key factors which can be considered with respect to the frictional resistance or skid resistance of a surface, one is pavement surface and material characteristics. So, pavement surface characteristics, as I especially mentioned, is in terms of the surface texture, which is defined as terms of surface asperities. So, you can see ranging from fine roughness of individual aggregate particles. Here this is an exaggerated view, you can see these are the fine roughness of individual particles which can form a part of your micro texture, to larger surface deviations. These are larger surface deviations specifically which is from your gradation. So, deviations is spanning several feet. So, this is spanning forms your macro texture in this particular large surface deviations. So, this specifically comes under your macro texture. Now, pavement surface material characteristics also plays an important role. What type of aggregates you are using? Aggregates, if those aggregates gets polished easily, then definitely it will make your surface more slippery in that case. Mixed characteristics, it will look into your binder which is present, your gradation which is there, texturing patterns, because normally you create a texture through your mixed gradation also. So, define surface texture and influence its long term durability by determining resistance to polishing, because aggregate should not get polished, abrasion and wear under traffic and environmental conditions, and how this surface texture gets affected in the presence of different environmental factors also. So, you have two important factors which is related to the pavement surface, the road surface, which is the surface characteristics and the material characteristic. Then you have as I mentioned, the vehicle operating characteristics, because it depends upon your maneuvering speed also, or we call the slip speed also. Third is tire properties. Now, you know very well, if you are driving on a wet surface, you will prefer to have a new tire, because there are treads are there, these which are there in the tires. So, that tread pattern is there that allows the water to skip. Whenever you see, whenever a vehicle moves over a wet surface, the water is moved in the form of a splash also, and it gets removed with the help of your texture as well as these treads which are there in the vehicle tire. So, you always prefer to have a new tire when you are traveling on a wet surface. So, it depends upon the tire properties, specifically tire tread design and its condition, because worn out tires may be there later on when these treads gets reduced. So, those may be worn out tires. And tire inflation pressure, because this is usually if underinflated tires are there, in that particular cases these depths of your treads gets reduced. So, they again become challenging when you are traveling over a wet surface. So, another characteristics is with respect to the tire properties, and last one is an environment. As I mentioned, it is quite safe and compared to when you are making a movement over a dry surface compared to a wet pavement surface. And in addition, thermal properties, because your tire rubber also gets expanded because it is a viscoelastic material, it changes with the change in the temperature of what is the environment, the temperature of the surrounding. Water and snow and ice, if they are present, definitely the vehicle friction is further reduced when the tire contact fails to reach the pavement surface due to any ice or snow buildup which is there on the surface. Contaminants may be there because dirt, sand which may be there, or any oil spillage is there, that further reduces your tire pavement friction. So, in addition, these are the important contributing factors: your surface characteristics, vehicle operating characteristics, your tire properties and environments. These are some of the main properties. Now, when this interaction comes into picture, tire pavement interaction, specifically two components are important for this development of the friction between a tire and a pavement surface. So, we say tire pavement friction mainly arises from two components. One is adhesion component, which is a molecular bonding or say interlocking between the rubber and the pavement surface. So, this is one component which builds up the friction or the skid resistance, and we put this particular one under the heading of the adhesion. And second is the hysteresis component, because this is energy losses from repeated compression and recovery of the tire rubber. When it passes over the surface irregularities, it regularly experiences a compressions and the expansion also when it passes over these surface irregularities. So, this particular one normally gets dissipated in the form of heat and is a component for your friction resistance. So, these adhesion and hysteresis forms two important components which contributes to your pavement tire friction. Now, specifically, when does a adhesion dominates and when does a hysteresis dominates? So, specifically, if a non-slippery surface is there, basically in that particular case, you have a good amount of frictional which is available from your adhesion. So, on skid resistant surfaces, initially fresh new surfaces are there, adhesion dominates where the interlocking is good enough and the bonding is good enough with the binder, the road surface and the tire rubber. Whereas, the hysteresis is in that particular case plays a little role compared to when on slippery surfaces, hysteresis, because the tire gets deformed because of surface irregularity, and then in this adhesion is not playing a role specifically when the surface is slippery. So, at that particular one your hysteresis dominates, and hysteresis normally is not affected by the speeds which are usually encountered on the surfaces. So, that is why hysteresis specifically in wet conditions play a very important role. So, adhesion decreases, whereas adhesion decreases with the speed on wet surfaces, making hysteresis, which is relatively more important because it does not usually gets impacted by the usual speeds encountered on the surfaces. Now, this hysteresis is because of the we are experiencing the compression and the recovery of the tire rubber over the surface irregularities, and surface irregularities are more importantly related to your texture of the surface. So, surface texture enhances hysteresis, but more importantly provide channels. Now, this surface texture, because you have the vehicle tread tires, treads are also, they also provide the channels, and your surface texture also provides the channel. So, provide channels for water escape, enabling the tire pavement contact. So, this again plays an important. On flooded pavements, water is partly splashed away, but primarily drained through tire tread grooves or pavement voids and textures. So, this surface texture and your condition of the tire plays a very important role specifically under wet conditions, and the hysteresis is the component which plays a more important role specifically under wet conditions at when you are having the slippery surfaces, that is means the chances are when some water is present over the surface. Now, how do we make these measurements? If you want to make the measurements at the actual speeds at which a vehicle is moving, so there is one quite popular method is there for measuring the pavement skid resistance, that is high speed speed friction measurement, which is usually say full scale test tires. So, this is one the locked wheel test which is there as per the ASTM guidelines is 274, where what is there, you have a skid trailer which is towed and it is moved at a speed of around 64 to 96 kilometer per hour and evaluates the skid resistance in actual service conditions. So, it moves on the actual pavements in this particular speed ranges. So, and at this particular speed range, again in this particular this is ASTM E274 skid resistance of paved surface using a full scale tire. So, it is a actual field test which is there and it is highly preferred. So, at this speed water is sprayed ahead of the tire, one or both wheels, there may be one wheel or two wheels which are locked, and the resulting resistance is measured as the torque on the trailer axles, and this particular is converted into a skid number, or we call it as a friction number. And if this value is high, we say that the surface is having higher friction resistance. So, the friction number or the skid number is a factor which is usually represented through these locked wheel testers. So, the result of these locked wheel tests are reported as friction number or skid number, and which goes with this particular expression of friction number and at a given velocity, because usually done at say 60 kilometer per hour. Then this is what we use your velocity of the test tire, because usually they go in miles, so 40 to say 60 miles per hour is there. Coefficient of friction, tractive horizontal force applied to the tire which is there, vertical load applied to the tire. So, this is if we need to work it out when we different units when we look for the measurements in kilometer per hour. So, speed as I mentioned typically ranges from 40 to 60 miles per hour, which otherwise in kilometer per hour is 64, because it is given as per ASTM this description. So, lower skid number invites safety hazards and would require immediate action. On the basis of the skid numbers, even our manual which is there for manual for construction and supervision of bituminous works, it says we can decide about the maintenance levels on the basis of the skid number or friction number also. So, the minimum desirable values of skid number for 3 levels of maintenance are given below. So, you can see level 1 which provides for highest level of comfort and convenience and safety when the skid number is minimum 50 in that case. Level 2 to which the road deteriorates from level 1 after 2 to 3 years of use before fresh maintenance is implemented. So, this is for skid number when skid number is 20. If it is less than that, so minimum 35, the minimum level necessary to protect the investment and provide reasonable levels. So, this is the minimum level of skid number which is to be required on a surface. So, this is given by manual. So, on the basis of these skid numbers, we can look into the maintenance part. And as I also mentioned that this plays important roles in other aspects also, the frictional resistance and skid resistance. So, it plays a key parameter in highway geometric design. And where do we play a role? It plays a role to determine minimum stopping side distance, minimum horizontal curve radius, minimum crust, vertical curve radius, maximum super elevation on horizontal curves, where all these things are. So, only one I will discuss here, just here is the braking distance. So, if a vehicle needs to stop over a particular surface, how much time it or how much distance it travels before it safely stops and protect itself from some say obstruction which is there on the surface. So, on a level road, just for an example, braking distance is usually derived by equating. So, initially it is moving at a speed of v, so it has a kinetic energy. So, it has to apply brakes, bring it down with the help of the frictional resistance. So, what is done? The work done by the frictional force in stopping the vehicle is to be equated to its initial kinetic energy. So, if F is the maximum frictional force which can be developed over the surface, L is the distance in which it can stop. If this is the distance, I will say in which it can stop. So, then the work done against the friction equals the vehicle's kinetic energy. So, this is your frictional force, this is the distance which it takes before it stops in this particular one. So, and what this particular one is your you have, this is coefficient of friction, which is F is equals to F into W, where W is the total weight of the vehicle. Now, what we are going to equate here, we have the kinetic energy, half mv square is there. So, it is W by g v square by 2, and we are going to equate it with the our work required by the frictional the work done by the frictional force. So, kinetic energy is equated to this frictional force into the length. So, FWL. So, here we have the, this is the kinetic energy and this is the work done. So, this when they are equated, we get the braking distance as v square upon 2gf, where v is in meter per second. Now, on the basis of this particular expression, we can work out for various design speeds how much length is required for a safe stopping of vehicle. Now, in addition to this one, you can see there is a lag distance is mentioned. What this lag distance, I am not going into depth of it. Lag distance means as soon as any vehicle user finds any obstacle, some time is lapse before it applies a brake. So, he need a certain time to come into action. So, this is normally a PEEV theory is there. So, how much reaction time is normally required. So, during that, when I first see that particular object, and by the time I apply the brakes, so some amount of time is lapsed. So, that particular, at that moment of time I am traveling at the same speed. So, that time is usually 2 to 2.5 seconds, and I will travel at the same speed. So, that will form my lag distance, and then I will apply the brake. So, after applying the brake, which is known as my braking distance, I need this much of length to safely stop my vehicle before encountering any damage with any obstacle on the road surface. So, this is what it is given here. Stopping side distance is usually, when v is in kilometer per hour, it mentions it is the distance travelled at the standard speed for the initial time, and this is the distance travelled during the braking action. So, on the basis of it, I can work out this particular braking distance. Now, this braking distance, as I have seen, is highly dependent upon my coefficient of friction. On the basis of this, our codal guidelines specifically, like, and I am giving just one example how this friction is involved in the geometric design aspects also. So, we have IRC 73 2023, which is geometric design standards for non-urban roads, where it says when one is traveling, as we have this already, this expression is there, LV square upon 2GF is already there with us. So, it says how much distance is required. So, we have, as I mentioned, perception time, the lag distance, which is with respect to the perception time, how much time it takes to analyze the situation and applies the brake. So, a standard perception time of 2.5 seconds is taken, and on the basis of that particular one, it takes a certain at whatever speed it is traveling, it will take this much amount of as your lag distance, and this is what the braking distance is. So, this braking distance will consider your lateral coefficient of friction. Now, here you can see at smaller speeds the lateral coefficient of friction, because it is traveling in the longitudinal direction. So, you can see it is longitudinal coefficient of friction. So, this is 0.4, 0.38. So, while computing this specifically the braking distance, I need to work out the F, coefficient of friction. So, here you can see in this particular one they have assumed, and this coefficient of friction, longitudinal coefficient of friction, decreases with the increase in the speed also, and on the basis of it, so this much distance is required for a vehicle to apply brake and finally stop. So, as you have a good coefficient of friction, you can stop the vehicle in a smaller distance. So, the surface resistance of any pavement surface is very important from this particular aspect. Now, there are various equipments which are used for measuring the pavement surface resistance or the skid resistance, and some are the one which can be used at a laboratory scale, some which can be used as at field scale, as the locked wheel tester which we discussed before is the one which is preferably used in field, where you can move at the same speeds at which actual vehicles are moving. And there are few more one which are quite often used to capture some or the other characteristics related to the pavement skid resistance. One is the sand patch method which is there. Second is British pendulum tester. This we briefly discussed when we discussed about the aggregate characteristics also, polished stone value. Then dynamic friction tester is there. Circular track meter is there, many a times referred as circular texture meter also. We will briefly discuss about it. Now, sand patch method, as I mentioned, the micro texture and the macro texture plays an important role specifically. Now, and the macro texture is the specifically the one where the surface irregularities are there because of the specifically derived from the gradation. So, this test is suitable for research, this specifically sand patch method, and to determine the average macro texture depth of a surface, because as I mentioned, this is important aspect. Macro texture plays an important role for the hysteresis part and for having the a good contact with the tire rubber, specifically under wet conditions also. So, the macro texture depth values derived from this test method can be used to compare the pavement skid resistance capability. Different surfaces can be compared with this particular one. And what is done? It is a simple volumetric test. What is done here? It involves a spreading of a known volume of a material, specifically a sand is there with a typical gradation on a clean and dry pavement surface, and for this given volume we are going to measure the area which is covered and subsequently calculating the average depth between the. So, once the area is known to us, volume is known to us, we can work out the average depth. So, that is what your mean texture depth can be worked out. So, the average pavement macro texture depth using the following expression, where this is the volume of the one which is spread out, and D is the dia, where how much of for how much dia it has been spread out. So, you can see this is that standard sand volume which has been spread, and then we measure this dia, and when we get this mean texture depth. So, this is quite simple, and with this particular one we can work out the one which is having a higher mean texture depth is going to have a higher specifically say macro texture, and is expected to give a higher friction resistance. Now, the other one is a British pendulum tester, we discussed previously also under aggregates. So, it is a dynamic pendulum impact tester which is used in field also and in laboratory also, and it is the one which typically captures the micro texture, because individual aggregate characteristics or the rugosity of these aggregate particles are captured. This test involves a measure of a frictional property, micro texture of surfaces. Specifically, it can be done on say specimens prepared at laboratory subjected to different polishing levels, or it can be done, the test can be done using this particular one on actual surfaces also. So, the British pendulum tester measured the friction values. You can see this is a pendulum, and this pendulum is allowed to move over that particular surface which is prepared in the laboratory or in the field, and this when it slides over this particular one, there is a graduating scale which is there, which is starts from 0. So, if it has a higher friction, it will rise to a lower height. So, you will have higher graduation numbers. So, when you prefer to have, so you can compare with this particular one. So, if it rises to a lower height, that means the surface where it has finally interaction is there is rougher. So, this is how it can be compared. So, the British pendulum tester measured friction values in terms of British pendulum number, BPN number we call it, or BPT also in sometimes, or polished stone value in case of laboratory prepared samples, which represent the frictional properties for flat surfaces and polished accelerated polishing wheel specimens which are prepared in the laboratory. The higher BPN value, as I mentioned, indicates the higher friction between the slider and the, because it will rise to a lower height and it starts from a reading from 0. So, that means there is if this higher number is there, that means a more of friction was there between the your rubber slider and the test surface. Generally, a 5 swing of the pendulum you for any particular surface you make repeated the determinations of this particular number. Now, here as I mentioned, you can have these samples which are there prepared at laboratory when you are checking ensuring the polished stone value of aggregates, when you want to see how susceptible your aggregates are polishing. So, they are prepared in the laboratory in this matrix and then they are subjected to this accelerated polishing action. And then finally, these the one which are already tested, this particular one is you can have the one which are without subjecting to the accelerated polishing machine and the one after subjecting these two accelerated polishing machines. So, you can work out the difference between these two. So, the polishing of aggregates is carried out for hours using accelerated polishing machine, and what we arrived is a polished stone value which is usually there for aggregates. And if you recall, we mentioned that for aggregates to be used in wearing courses, we at least want that the polished stone values of the aggregate should be greater than 55. So, this is again one test. So, British pendulum, this can be used for measuring the frictional characteristics of specimens in laboratory also and in field of actual surfaces with the different slider arrangements which are there. Now, this is another test, a test setup which is used to get the frictional measurements with the variation in the speed. So, dynamic friction tester measures surface frictional properties as a function of speed, and specifically it can be done again laboratory prepared specimens, or it can be done preferably in the field also. And this test can be conducted in the presence of water also, in the absence of water also. So, it is used to determine the relative effects of various polishing techniques on materials or material combinations, because laboratory prepared samples I can do some accelerated polishing over these laboratory prepared mixed samples, and I can take this particular one in the field and measure this variation in the friction with the speed of the field samples also. So, here you can see it is having this particular horizontal disc is there which is lower down. This is a bottom view of this particular dynamic friction tester. This is how it looks from the bottom. You can see these are having these rubber sliders are there, 3 rubber sliders are there. So, the dynamic friction tester consists of a horizontal spinning disc fitted with 3 spring loaded rubber sliders, and when it is brought down, so it is rotated to the desired speed and then it is lowered down. So, these rubber sliders touches your surface, and then with the torque you get the and with the revolution speed you get the variation of your friction with the revolution speed. So, as the disc rotates, the rotational speed decreases due to the friction generated between the slider and the surface. So, the torque generated by the slider forces measured during spin down is then used to calculate the friction as a function of a speed. So, this provides a maximum tangential velocity of 90 km/h. So, this can give you an information. So, you can compare the different surfaces with the help of this dynamic friction tester. And you can have, if you prepare laboratory samples, you can have on fresh samples, you can subject them again by some means of polishing, and then you can again use this dynamic friction tester to get its information about the friction values. Now, the other one is a circular track meter, specifically the texture which we are comparing through the getting through the sand patch method. We can better get this particular information from the circular track meter also, and it is and this particular one is specifically because we want to have correlate this particular one specifically with the dynamic friction test measurements. So, we will prefer to move it at the over the same track that is used for the dynamic friction tester. So, because then we will get an idea, because there we got the friction with respect to the speed, and we want to get an information about the texture of the surface also. So, it is run mainly over the same track where we have run the dynamic friction tester. So, and what it consists of, a charge coupled device, specifically a laser displacement sensor which is there, that is mounted on an arm that rotates clockwise at 80 mm. This it rotates clockwise at 80 mm above the surface, such that the displacement system follows a circular track having a diameter of this particular one. And what it captures, there is a sensor which captures the macro texture depth. So, this is an important part, and it, as I mentioned, it can be used for both laboratory investigations and field investigations. And what important it captures the macro texture profiles in terms of the mean profile depth. So, the overall you will have the lowest one and the highest one peaks will be there. So, it will help you give you the mean profile depth with this particular one, and this mean profile depth is well correlated with your mean texture depth. So, I can say this particular one, specifically your mean profile depth is a 2D measurement compared to what the 3D measurement which you have in the volumetric sand patch method. So, it has been found that the average of the mean profile depth which you get from the circular track meter for the 8 segments, because it divides into 8 segments using the circular track meter, is extremely highly correlated with the mean texture depth and can replace the volumetric measurements for the. So, then you get more accurate measurements, and it can replace what you have got from your mean texture depth. So, the recommended relationship for the estimate of mean texture depth from the mean profile depth by the circular track meter, this is a standard expression which is used for converting your mean profile depth which is obtained from circular track meter to your mean texture depth which we get from the sand patch method. So, the mean profile depth is mainly a 2D estimate, where of the 3D mean texture depth, and is defined as the average of the highest profile peaks across 8 segments, because it is divided into 8 segments and over which this particular one is measured. Along with it, the root mean square, a statistical measure, is also computed with this circular track meter, and which gives you how much the measured profiles deviate from its best fitted model profile. So, this is an additional information which you get from the circular track meter. So, we have discussed some of the important features which are related to the skid resistance or the frictional resistance of pavement surface. What are the key properties over which it depends, including the pavement surface, the vehicle, the tire, the environment, and how the measurements can be done in field using the locked wheel tester, and there are certain other setups which can be used in the field also, as well as laboratory. We have the British pendulum tester, we have dynamic friction tester, we have the circular track meter with us, we have the sand patch method which can be used at laboratory as well as in the field sections. And then we briefly discussed about the usefulness of these frictional factors, where we discussed about the coefficient of friction in terms of the braking distance. So, this is all about for today's lecture. Thank you so much.